Good morning, everyone. It's foreseen we do the talk in English. I don't know if are people speaking English in the room or only speaking English. Okay, then we continue in English. Otherwise, we could have done it also in Dutch. Welcome. So today we like to talk about Terumo's journey to a factory of the future, from a strategic choice to a successful transformation. So let's start with what Terumo stands for. So we stand for contributing to society through healthcare. That's our motto, and that's also what we live at Terumo. Briefly, Terumo's corporation, what do we do? So we are a Japanese company, headquartered in Tokyo. We are manufacturer of medical devices, more or less 5 billion euro turn revenue, and we operate in 160 countries. We are almost 25,000 people, and we are representing Terumo Europe, so the EMEA region. We are headquartered in Leuven, Belgium, with the EMEA organization. So since 51 years present in the European area, while the company is 101 years old. So 1,500 employees in European region with approximately 700 million revenue. So we have manufacturing sites in Belgium, actually 2 factories in Leuven, one in Liverpool, UK, and one in Deventer, Holland. Also, we operate from our distribution center the whole region of EMEA. All right, so we started our journey of transformation out of the question we posed is, why should we do that? And to compete in today's days, you have to be good in many things, but you have to excel in some of the disciplines. So the lead, you have to be good in almost everything and excellence in many things. So each and every employee, we try to let them see the flow of value from customer, and also see this, our product, from start of manufacturing towards the delivery of the product.
Okay, good morning, everyone. I'm Herman Pinxten. I'm responsible for transformation in Terumo Europe. Let's zoom in on our actually strategy map that we created somewhere 2018. We started our journey at that point in time, and we started with actually collecting all different angles from a strategic point of view. What are external factors? What do we need to do to be good? What are internal factors? Where did we fail in the past? And how we can combine in a strategy map. And we came up with 4 actually fundamental pillars, which are not that different from many companies. We should serve our customers and we should serve the patient because we are medical devices. We should go for zero, and go for zero we mean 0 quality issues, 0 safety issues, and 0 effect from our manufacturing lines, meaning yield at a perfect stage and also the impact on environmental minimum as possible. Of course, we want to optimize our costs, and in medical devices, we have some challenges on regulations, so also there we have a pillar on compliance. Doing so, we actually thought of what kind of improvements do we need actually to get there over the long term, 3 to 5 years from that point in time, somewhere 2018. And we came up with 5 fundamental initiatives. First of all, there is talent. Second, there is long-range strategic plan. There is the excellence system that we want to drive. And of course, there is also growth, new products, and also policies and so on. In this presentation, we will zoom in actually on the first 3 a little bit, where we actually, of course, will have an emphasis on the technology which is embedded in the long-range strategic plan. Of course, if you want to go somewhere and if you want to get results, you need to keep scorecards. That's what we did, and what we typically do is keep scorecard over multiple years. Not just 1 year, not just the short term, but we keep scorecards over multiple years, how we can get there for the 4 fundamental pillars: service, go for zero, gross profit, and compliancy. Let me zoom in first very, very briefly on talent. There is a war on talent, there is a war on technology talent, and we want to do that as good as possible, and for that reason, we want to make it comfortable and effective to work in our organization. To do so, we believe in 2 things. First of all, we should organize our people and our talent in teams. Secondly, we should connect these teams into flows. Teams connected into flows, that's exactly what we did. We actually created shop floor teams many years ago. We have an environment of cross-functional teams leading the shop floor teams. We have an engineering team actually doing the full industrialization of processes, building equipment, testing equipment, and we do that in-house because we believe the strategic elements of technology we need to own ourselves, and we have our own product and process development team. Second pillar in our strategic plan was a long-range plan on technology. What do we need the next years and also in the past years to be successful in the long range? And of course, there are some logical pillars in, like capacity extension, because we have some growth, like automation and like digitalization. But to start with, we had a thought, what is actually the role of technology in the entire transformation that we want to make? So if you look at the 3 different strategic directions you can get, you want to be good in cost, you want to be good in customer intimacy, or you want to be good in products. We actually had a thought, what is actually the role of technology in these 3 roles? And we came up with 3 different angles. First of all, on the product, we should make sure that the manufacturability of our products is really good and is supported fully by technology. Processes that are at the high end, that control quality, smart processes that are enabling us to have good products. Secondly, yeah, of course, if we want to serve our customers, we need to look in flexibility and capacity. Flexibility is a challenge. A lot of our customers, the new trend is a lot of customizations, how we can drive customization in our products. And then the last one, of course, if you want to drive cost, and many companies are on that angle, you need to have smart processes, you need to focus on efficiency. So we focused on enabling work systems, enabling small things that can optimize our cost.
So based on all of this, we had put together our investment plan for not only 1 year, but we looked forward in 2018 towards 23, and now we are looking already till 2030. So what we see here is we focused in the first instance on capacity extension, also on technology, so FMP square, where I come in the next slides in more detail on it, so that's flexibility. And also we introduced quite some automation by means of cobots and robots. Yep. So FMP square, this is a platform, a modular platform, that gives us the possibility to build on existing machine enlargements and also make more modules that can do operations in the process. There's normally a film that starts. So here you see the modularity, so we can open the machine, bring in extra modules, and so on. It's a plug-and-play system, so ready for Industry 4.0. It has intelligent communication that is foreseen in the racks underneath the machine, so we can act in a flexible way, change position of workstations, and have all electronics and feeding towards the machine easily adaptable, compatible, and have that intelligent communication so that can steer all the positions. So an example of this platform is our tray filling system. So we are making a kit with different components. As you see underneath in the plastic tray. So this machine, and we could let the little film run so you have an impression on how this functions. So this is an FMP square machine we developed, and we will also further integrate in a complete assembly process as an end station. So we put all necessary components in the trays in an automatic way, like you see here. This is a feeding of a needle that comes into it. So this process was traditionally in 2 teams of 6 persons that we manually did that exercise. So now we have 1 operator mostly that can operate the whole process. So you can also integrate hand labor or labor together with the machine, as you see here as an example. So you have all flexibility in this way of working. Next example is how we use cobots. So we introduced cobots in catheter packaging. So underneath you see a catheter, so how it's packed in a sleeve that we have to seal and make ready for sterilization. We had an issue, we could not completely automate that process because there is a quality check where you see the operator standing. You need to feel the surface of the catheter by your fingers, so little burrs that could occur. We did not find a technical solution on how to automate that. Therefore, we have took the option to keep an operator for this quality check. You see here the operator checking by feeling and also a check of the form of the front of the catheter. So you see it feeling through the fingers. And then it's put on a mounting plate, like you see here. And then the cobots are taking over the rest of the process. The packaging, the sealing. We also took care of ergonomics on this machine. So not every operator has the same length. So we can adjust the control table where the manual operation is done in height. And automatically the rest of the process, the cobots are adapting themselves to the new height who is set for the operator. This as an example of how we introduce cobots in our operation.
Okay, 2 nice examples of how we drive technology actually to get our strategic goals fulfilled. The next one I want to emphasize is if you look at product itself and enabling the processability towards our products, we also have many different examples of inspection systems, control systems and so on, where our belief is actually we should make our machines that smart that they each cycle confirm quality. That means there is no way that we can rely on inspection in the end, that we can rely on statistical controls and so on, that many. The ideal situation is each cycle is confirmed by the machine and the machine knows it's correct. That means we have some predictive tools and needed in some cases some predictive tools. I want to highlight one at the right side here where we have actually a film where there can be industry standard, but for us, if we form that into a blister, there is a risk that this film creates a hole. For that reason, the engineers came up with actually an excellent solution to do web inspection, meaning we control the picture of the film, and we see actually based on the pattern on small islands in that film that are even invisible for the human eye, we can the risk that due to forming of the blister, there might be an issue and an insterile product. So this is trending, this is making sure you can do the right interpretation of the pictures and so on. This is something we apply in many different areas into the manufacturing. Let me talk then a little bit about the second layer that we had in our strategy. It's about manufacturing processes and equipment. It's also about digitalization. On digitalization, we did many things. And of course, when we started our journey, we had the same reflection as many companies. What kind of systems do we need? But we went out of that path and we start reflecting. We have an MRP. We have a lot of systems. What do we really need to enable our manufacturing and our business? And there, if you look at our needs, the first one for us was daily management. What kind of information do people need every day, every hour, just to control their manufacturing lines? The second one for us was, okay, how we can excel in gathering production quality data, because in our world, we need to comply. It's a lot of regulations. We need to have certifications for each of the products, so we need to collect this data automatically. And we came up with 2 solutions for that. The first one is an OT data lake, where we connect all of the machines digitally to a data lake, and we created an operator portal. And the second one is electronic batch record. The first one, I would like to zoom in a little bit on our solution.